Okay. Hello, everyone. Welcome to session 2. Also, I cannot screen share. Uh, Assuming that everyone's looking at the slides, I'll start talking. I'll stop if we actually need the images, but basically, first thing, if you have any technical difficulties, okay, there's screen shares good now. Um, so I'm actually gonna share my entire screen this time since last time we had some issues with switching screens around. Um, okay, first of all, can everyone kind of like read the slides? Okay. All right. So if anyone has any like technical difficulties, so I don't know, maybe you can't get like VS Code to work during usually generally outside of sorry, not even if it's during a session, you should probably just go to the help channel on Discord, Zoom chat. Okay, I guess if you have technical difficulties during session, you can probably just like DM your mentor or something. But other than that, we'll try to reserve the Zoom chat for session content. So if you haven't already, sign up for the Discord. I believe I'll send you the link at the end of the session if it doesn't show up in the slides later. And last I checked, I'm pretty sure the bot is not functional, but if your mentor wants to like create a group chat for everyone in your group, you can do that. So this session, we are going to be going over classes and objects, and then we'll be starting our game. So before we start, why use classes and objects? Well, in short, it's just makes it easier to reuse code. It's more efficient. So I guess one way to think of an object is it's kind of like a more flexible box than variables. So variables usually you can only store like strings, integers, or what else? But it's pretty restricted. But an object you can put a lot of things in. So you can store like lists in an object, you can store variables in an object, and like later on we'll also get to how you can like call functions on an object. So basically it's like a much more flexible box than a variable. Yeah, so once again, objects are like a good way to group things together, and they're better than lists because you can think of objects being a bit like a dictionary where you have like a key for each value. So it's like, oh, rectangle X, for example, is 50. And the difference between objects and dictionaries is, well, objects are just going to be easier to use. So you can use like the dot operator, as you can see here, to call on like a specific property of an object. So here I think we have an example, if I can find it. So for example, if I wanted to find so just a quick look at the slide again, right? Last time we used a rectangle object in Pygame, if you guys remember, and we kind of accessed their X and Y variables. So an example here is I just import Pygame and then I create a rectangle object called rectangle1. So you can see it over here. Give it some X value, Y value, width, height. And I can actually, the simple way to access these values is I just print so rectangle1, this specific object here, what's X value? So if I run it, you'll see down here, it shows 0. So that's the X value there. Yeah, so I think I mentioned this already. The way that you access like the parts of an object, if you will, are you use the dot operator. Yeah, so we're going to be getting to our first exercise now. So what you want to do is you want to download both of these files. You notice their difference. And one of the important things you should note is, hang on. You want to like make sure you name leaves.py leads.py, like when you download this file over here, make sure you name it leads.py because the other file actually calls it by the exact function name. So if I can just find it somewhere, right? So it's like you have to name it this. And before we start the exercise, I'll just like give a few, not necessarily hints, but just to kind of simplify things. Here you have your tree trunks. So these are like all these Pygame rectangles which are drawn. And this is the, if you run the code, you'll see there. You'll see these are your 3 tree trunks, and this is like your first leaf. I mean, you're supposed to place it on top of the tree trunk. But yeah, so this over here is like saying, okay, let's make leaves 1 a leaf object and assign each of its values. Hang on. Yeah. Assign each of its values. Give each of its variables some values, if you will. Give it some properties. And that should be that. So yeah, everyone can start now. And if you have any questions, you can. Yeah, we also need breakout rooms, but just DM your mentor. Then we do like 15 minutes maybe.
Yep, that sounds good. The rooms are all open now.
Okay. Um, oh yes, entire screen. So I guess I'll do like a super quick walkthrough, although I'm gonna assume like most people were able to figure it out in their session, like with help from their mentor. But the main thing that we really want to do is just create like some more leaf instances. It's a bit tedious, but one of the shortcuts I would use is I would highlight the text and then I would go and nope. There's a way to do this. Basically, it's kind of like a control F. It's like a find and replace, but only for a certain section of the text. Okay, if I can't do this within like the next 30 seconds, I will not waste time. But let me see if I can figure this out. Whoops. What is happening? Okay, so I go here, and maybe I go maybe I do Control F. Okay. That's it. Oh, okay. I think this will work. So then we go here and we go leaves. Let's just call it leaves 2. Right. And replace all. There you go. So yeah, so for future reference, if you guys ever need to like type, generally you want to use like whatever classes or for loops to avoid excessive typing. But if you need to like replicate a chunk of code and just change everything with one sort of name to another, then you can highlight it and then you Control F. So it's like Control Find, and then you type. But this time it only searches. Bleh. Okay, I don't think it's working this time, but you'll only search within the text that you highlighted. It's definitely ways to do that. So now I'll just go over here. Now we have like 2 leaves. I'll just change up the positions to kind of show what's supposed to happen. I'll leave the colors the same. And oh, okay, that did not work. Oh, that's because it's 1000. Of course, it's probably off the screen.
You also need to draw it down.
Sorry, someone talk?
You need to put in the code to draw it. Right now you only created the variables.
Oh yes, correct. Thank you for the correction there. I believe it's somewhere here. Yes, use one. Yeah, okay. Perfect. Just change it manually here because I kind of forgot how the shortcut works. And yeah, so basically it's, well, let me quickly run the code first, see if it works. Yeah, so basically you want to create like a new leaf object to just like store your variables. And then you want to create you want to use pygame.draw.rect to actually draw the leaf with the using the variables below. And then obviously I'm not going to spend the time to rearrange them, but you just want to move the position until they're on top of the trunks. Okay. So next we have classes. So classes are like blueprints for, I don't know if blueprints is the greatest word, but classes are like a way to kind of like categorize objects in a way. So as you kind of see here, what you would do is you would create like a class called snake, for example, with properties called a name, color, and a species. And then what you can do in Python is you can create like instances or objects. Well, they're called instances, but basically when you create an object of a class, it's called an instance, and you can give it specific properties. So for example, like this first snake is going to have a name called Buttercup. The color is orange. And we'll kind of learn how to use these as we go. So I guess one more thing to note is that objects that are created from a class, they have like the properties are unique to the object itself, right? So the class might be like, okay, we have these properties that are universal, but then for each object, the property is going to be like unique. So yeah, here's like a simple example of the class. And once again, we'll go through the parts like in the following slides, but basically you have the dog here, and it's like when you create the dog, give it a number of, make the default number of legs equal to 4 and make the default sound of a woof. Okay, so first we have like, once again, the init function. Because there's a fancy word, it's called the constructor that makes up the class blueprints. And so from my understanding, the main reason you use the init is actually so that you can give any object that is like like every time you create an object of a class, if you have the init function and you have like some stuff inside of it, then it lets you actually like access the object in the future. I won't go too much into that, but like mainly it's just, it gives it like starting variables, right? And I'm pretty sure you also needed to actually access the object later. I might be wrong about that though. Actually, no, you don't need it to access the object. So main thing about init is you can give it starting variables, and like especially if you go into like a more complex game, you'll have quite a few starting variables, and you don't want to like give those every single time. So that's why you use init. So init is, I'll actually try quickly pull up an example here, hopefully. When you use like the init function, you can give it as many variables as many arguments as you want. And basically, if I were to create like a person, so I would go say p1 equals person, I would be able to enter in like all these variables, right? Use commas to separate it. What else? Right, so I guess back in this example here, all these variables that I kind of like pass into the init function, they're going to be referenced over here. And I'll explain the self thing very soon. So we have properties. Once again, I mentioned this already, but they're like the objects variables, if you will. You can kind of see that So I guess like self, these I will go into more depth on this, but self is kind of like referring to the object itself. So you can say, okay, self acts kind of like a placeholder, and I will definitely show an example of this later, but you can think of this as like self.name is saying this specific object's name is equal to whatever you set it, right? So this is like, it's going to be different for each object once again. And yeah, this probably sounds a little bit confusing if you haven't like any experience with classes, but yeah, it is, we will go into that. But first we have our first quick question. And yeah. Also, if I know I didn't say it specifically, but you can review like the last 3 or 4 slides and you will be able to find the answer. So yeah, so I apologies, I did not mention this specifically. It was in the slides. I know it's going a bit fast, but the self keyword always comes first. And the reason for this is that, well, first of all, Python is going to be looking for this. And the way that self works is it kind of acts like a placeholder for, you can think of it as like the word my. So I guess an example of this is, oh, sorry, I'm not sharing screen, am I? No, no, no. Okay, that's not good. Let's see. Yeah, so self. You can kind of see how I'll show this code is probably a better example. So first, by the way, the self keyword, it doesn't have to be like called self. It can be anything, but you just have to make sure like whatever you use, it's consistent. And you know, just self is like the word self is kind of like a convention. So I just recommend sticking to that. And so basically this first variable here, or first value here is like kind of what are you going to use to refer to the object itself? So now, you can think of it this way, like this self.name here, it's like P1 is the self. Not sure if that makes sense, but so basically over here, I initiate like an object, a person object, and it's called P1, right? So in this case, self is kind of like the placeholder for P1. So instead of like printing self.name, I'm typing P1 because that's what the self is. So it's not, probably I didn't word it the best, but does anyone have questions? Does that not make sense to anyone? Yeah, I'll take that as no, and if it is confusing, you can just DM your mentor. You can even put something into the chat as I'm talking. Okay, so yeah, okay, yeah. So one of the things that we have to like note is you'll notice like when I create the person object, self is not actually a parameter I pass in. Once again, it's kind of just like that. What do you want the placeholder value to be called, right? So yeah. Next, we're going to build our first class. You know what? You do not have to go along exactly. Like if you want to make sure nothing is if that everything works, you can follow the examples completely, but I would just suggest you can be creative. Since I already have this here, sure, I'll make the new one. So how do you create a class is first you use a class keyword and then you type in the name of the class. And usually like convention is that you use something called like Pascal case, which is basically for every word that you have, make it like capitalized. So like fun snake or something. And then you want to use one semicolon. Is it semicolon? No, one colon to like mark that your class is beginning. Next, you want to use like init to kind of tell your code like what should I do when I first create a sorry, let me type this up. An instance of this object. And once again, like the self keyword is here so that you can actually have like you have a way to like reference the object itself. Like if you didn't have self, then what would you put before the dot to actually like call the object? Like you wouldn't know. Okay. So we'll have self here. And then we'll have my name. Sure, whatever. I'll just type name. And everyone can like follow along unless you really don't want to. Dot name equals name. Sure, whatever. I can name it this way. To kind of see like when we create the object and we pass a variable to this parameter here for my name, then we're going to set the objects like the name property of the object itself to whatever we passed in as a variable. Like if you don't actually set this, you can have it like default. You can just be like, oh, the default name for snake is snake. Then if you created like a snake object, so I don't know, snake equals snake, and you said Bob. This Bob here actually does absolutely nothing because it's being stored in this my name variable, but this my name variable is actually not being used for the snake. So if I just quickly show what happens. Oopsie. Yeah, sure, it's snake K. So as you can see, like the name variable for this snake here is actually still set to the default because this argument here isn't being used. Okay. So yeah, I kind of already did the next step, but you want to type in whatever you want to call your objects and then set it equal to, say, the class, and then you pass in parameters. So in this case, I only made one parameter for my snake, so that's going to be snake. Sorry, not snake, the name. And I'm also going to change this self.name equals back to my names just to like illustrate. Yeah, so once again, don't include like the self argument. It's automatically included. Okay, just for like illustrative purposes, if I remove this self, then like there's basically no way to actually reference the object itself, right? It's like, how do you say the name that belongs to the specific snake? So apologies if I'm not doing a great job with this self-explanation, but it's kind of makes sense as you go through it. Yes. Right. So yeah, another thing that kind of they mentioned in this example is whatever you put in the init statements is going to be run every time you create an instance. Oh, and yo, if you name like the variable, if you give like two objects the same name, it's not going to cause an error, but it's just going to be like really annoying to, it's really difficult to actually specify, if not impossible, like which one you want to reference. So don't do that. So as you'll notice here in my code, basically what happened is the first snake gets created and it runs this code in the init function. So first it sets the name property of the snake to my name. So in that case, it's Bob, and it prints, right? And then second snake gets created over here and same thing happens. And then lastly, we have this line that's like, oh, print this snake's name, right? So it gives us Bob. Okay, so now we're to our second question. Quick question. And hopefully I have explained it well enough that you'll be able to figure it out. Okay. Okay, full screen. I guess I'll quickly walk through the reasoning behind the quick question. So basically we create a class called person and we define the initiation as, okay. Yeah. we define the initiation as just self-defined innate self, and it says, oh yeah, self.name equals George. And I guess like I don't know what the rest of you kind of does, but the first thing I see is like, okay, there's no hang on. Yeah, okay, that's fine, Sorry, my bad. So yeah, basically you create this, it's kind of like everything you put like self dot whatever, it's kind of like creating a variable, if you will, in some ways. It's kind of like when you say k equals 20, like all these are, you're kind of creating like properties for the class every time you type self dot something equals blah blah blah. Basically what happens is we define the initiation. So when we create a person, we get, oh, sorry, I do not see how many people got this correct. So I'll try to go over it quickly. So we create the person, and first thing happens is once again it goes through initiation. So it says, okay, self.name equals George, and now print self.name. And if we quickly run that, should just print George. Yeah. Okay. Next. Okay. Yes. Okay. Before I go on. So another thing you can actually do with objects, which you definitely cannot do with like variables, is you can actually put objects within objects. And so you can kind of see on the slide here, the example they use is like you have the parachute, which you can put like a bunch of things into. So I'm actually not too familiar with like space stuff, but another kind of example of this what you might use in games is like if you have a character, you might want to attach like a gun object, for example, and then this gun object is going to have like a bunch of attributes and also like it's going to have its own logic for how it behaves in the game. So that's one of the reasons you might add like one object to another one. And so here like there's a quick example. It says create a snake and then also set the self.rect property, or I'm going to call them properties from now on. So I'll set the self.rect property of this snake to a Pygame rectangle. And if you wanted to access like the,
And you're not sharing your screen.
oh, dang. Sorry, my bad. Bleh. Silly. Okay, so basically I was over here, object can have objects, right? There's a quick Mars example, which I am not too familiar with, but so over here, basically part of the initiation of the snake, it says set the rect property of this snake to a Pygame rectangle. And if you want to access like the properties of the Pygame rectangle itself, then you can go mysnake.rect, right? So this is the rect. So now like this rect here is actually referencing an object over here. Just like make it clear, you could actually call this like shape, right? And so this shape here now is actually referencing the Pygame object, and then you can just access the X variable from that. The only reason I want to change it is just like not to get people confused with, oh, it has to be like rect.x because that's what we used last time. So this thing here is basically, it just references the object itself. Could be any object. Okay, so next we have imports, and imports, I mean, many of you have probably used this already with, for example, import Pygame is already an import, and how it works is it gives you access to code from another file. And so a lot of like modules that we import are basically just like bunch of, they're like big files with a bunch of predefined, like Pygame is actually one of those. It's just got a bunch of predefined classes and functions and logic, which just makes life easier for us. Yeah. So I will walk through kind of an example, or actually I don't have to, I can just use the slides. But for example, over here, if you have your main.py file and you want to import snake, then if you want to create a snake object, or if you want to access the functions in this snake file over here, I'll quickly create do some typing up, I guess. Actually, no, there's a good example over here. So over here, for example, it says from leaves imports. Yeah, so it's basically like from leaves, this leaves.py file, import the leaves class. And this basically just lets us use the leaves class directly over here. If you didn't type like from leaves, import leaves, if you just like import the whole thing, then you would have to change this to say leaves.leaves, just to specify like which file you're actually calling the leaves function from. Because there could also be like another one called like, it could be like a fancy leaves.py, right? That could be another file, and then they could have like a different leaves function. And once again, like I kind of mentioned this, but a bunch of the things that we import are actually like built in. So like import OS, for example, has like a bunch of useful things for directly interacting with the OS that would just be hard to do without like it'd be hard to do from scratch. And yeah, so Pygame, yes. Yeah, so here, like the from keyword, you can kind of think of it just like import a specific part of this file. And it's useful when you don't want to use like especially for large files, sometimes it's just not efficient, like for the computer speed to import the whole file. Usually you don't have to worry about it, but something to keep in mind. The other benefit of saying from snake import snake is that you can just type like snake directly instead of typing like snake, oopsie, snake.snake. So you don't have to specify. It's probably the main benefit. So yeah, now this kind of brings us to our first exercise and also kind of like getting started on our game. And so what we want to do is we want to make a platform class that makes it easier to create rectangles. And then the extra stuff that you can do is like you can add platforms that move, and then another thing you can do is like add logic that checks for when the platforms hit the edge, just make them wrap around. And there's like a bunch of other fancy things you can do. Think okay. Just try to use the classes in a way that like is most efficient. Now, I'm pretty sure the mentors will be checking the exercises. Yeah, okay, they will be. So if it's not like super efficient or something, like if there's something that you can do better, your mentors will let you know. So I just kind of leave everyone with this. And so I think we actually have like 30 minutes. We're going a bit fast, but I guess now is kind of the time, like in your breakout rooms, you can, ask whatever questions you have and maybe get a bit of extra time to like implement extra features, if you will. And once again, your mentors can help you with that. Like if there's something that we haven't learned, for example, just ask. Yep. I think we're ready for the breakout rooms then. We'll do like maybe, yeah. 30 minutes is probably fine. Yeah, so before we wrap up, we just want everyone to do an end of session survey. And then once you're done, you can feel free to leave.